Today we will discuss about experimental design. এটা আমাদের লাস্ট টপিক, কাজেই আজকে আপনাদের এই কোর্স শেষ হয়ে যাবে। This is experimental design. Okay. এক্সপেরিমেন্টাল ডিজাইনের প্রথম মডেল আমরা আসলে পড়ে আসছি, যেটা ছিল অ্যানোভা। ওকে, আপনাদের যদি মনে থেকে থাকে সেখানে আমরা several mean টেস্ট করেছিলাম, whether more than 2 means are equivalent. এক্সপেরিমেন্টাল ডিজাইন হলো planning of an experiment to obtain appropriate data. Okay, drawing inferences out of the data with respect to any problem under consideration. So experimental design is conducted to get the data. That is the goal. This might range anywhere from the formulations of the objectives of the experiment in clear terms to the final stage of drafting reports incorporating the important findings of the inquiry. Okay, this sort of experimental design were first conducted in agricultural fields. So in most of the time you will see the example will come out from those fields. So we are not looking for that experimental design today, that was ANOVA type. You know it is experiment. Okay, in your engineering field you do some experiment whether some machine can be produced. Okay, then you design things. Okay, so that is the experiment you have to do repeatedly. Okay, do and do again until it is perfect. So experiment is a thing you do repeatedly. Okay, and in statistics that experiment has a great role in conducting things. Okay, that you have to do that repeatedly. Okay, until it is done. So here we will discuss about factorial experiment today. Okay, not that CRD we studied in our previous class that was discussed with the name ANOVA. Factorial experiment is an experiment whose design consists of 2 or more factors, each with discrete possible values or labels, whose experimental units take on all possible combination of those labels across all such factors. Okay, so for example you have, say, 2 factors. For example, we talk about 2 by 2, 2 cross 2 or 2 to the power 2 experimental design, that we call it factorial experiment. So 2 in the power, if you can see it, 2 to the power 2. Okay, 2 squared sometimes you call it 2 squared. So 2, the power is the factor. Okay, and the 2 in the base, that is the labels. Okay, so 2 factor has 2 labels, so it will have 2 to the power 2, 4 factorial combinations. Okay, label combinations. 2 to the power 2 means 2 factor is with 2 labels. Okay, If it is 3 to the power 2, then 2 factors is with 3 levels. Okay, so power is the number of factors and base in the level of base in the is the number of levels within each factor. Okay, so that is the factorial experiment. Okay, so here we will discuss all about factorial experiment, that is full. A full factorial design may also be called a fully crossed design. Such an experiment allows the investigator to study the effect of each factor on the response variable, as well as the effects of interaction between factors on the response variable. Okay, so what is full factorial experiment? That is, if you have two factors and two levels, then you will have four possible treatment combinations. So you will have to get each and every cell with values, okay? None of them will be missing. None of them will be omitted, okay? So that is full factorial design. It is also called factorial design. You have to then understand it is full, unless they call it partial factorial design or fractional factorial design, okay? So that is factorial experiment. You will have some factor, you will have some levels, and for a full factorial design, you will have to have all the level combinations with values. For the vast majority of factorial experiment, each factor has only two levels. For example, with two factors is taking two levels, a factorial experiment would have four treatment combinations in total, and usually call a 2 by 2 factorial design. Okay, most of the time we are busy with accepting people. Okay. So next topic is fractional factorial design. Fractional factorial design is when you will not get all the values in that treatment combinations. If the number of combinations in a full factorial design is too high to be logistically feasible, a fractional factorial design may be done in which some of the possible combinations, or at least half, are omitted. Okay, you may not get all the logistic supports to get values from all treatment combinations, but you may also lose some information or data or values because of some natural disaster. Okay, for example, your factory and you have some treatment settings in say cyclone prone area. So in a cyclone you got damaged all those settings, so you will not get any data from that experiment. Okay, so you have to do then fractional factorial design. The simplest factorial experiment contains two levels for each of two factors. Suppose an engineer wishes to study the total power used by each of the two different motors, A and B, running at each of the two different speeds, 2000 and 3000 RPM. Okay, you know this RPM, rotations per minute. Okay, something like that. The factorial experiment would consist of four factorial units, motor A with 2000, motor B with 2000, motor A with 3000, and motor B with 3000. So you have 4 possible level combinations. Each combination of a single level selected from every factory is present once. This experiment is an example of a 2 by 2 or 2 to the power 2 factorial experiment, so named because it considers 2 levels, the base, for each of the 2 factors, that is the power of the superscript. So you will understand the levels to the power factor, okay? So that it has 2 to the power 2 means 4 factorial points. The notation used to denote factorial experiments conveys a lot of information. When a design is denoted by 2 to the power 3 factorials, so you will understand 3 factors is with 2 levels. This identifies the number of factor is 3. How many level is factor has, that is 2. So how many factorial experimental conditions there are, that is actually 2 to the power 3, that is 8. Similarly, a 2 to the power 5 design has 5 factors and is with 2 levels, and 2 to the power 5, that is 32 experimental conditions. And a 3 to the power 2 design has 2 factors, is with 3 levels, so 3 square means 9 factorial conditions. Factorial experiments can involve factors with different numbers of levels. A 2 to the power 4 into 3 design has 5 factors, 4 factors with 2 levels, and 1 factor with 3 levels. So it has 2 to the power 4 means 16 multiply 3, 48 experimental conditions. So this is how factorial design will come out. Okay, so we will discuss that with an example. If you have any question, don't hesitate to ask. Two factor experiments. Here we will have 2 factors. This is the simplest case. Consider we introduce the idea of 2 factors, that is 2 variable experiment, in the context of recycling material for roadways. Recycling of construction and demolition waste can greatly extend the life of the existing landfills, but any recycled material used in roadways must perform as well as the typical natural aggregates. To establish specifications for the strength of recycled materials, the experimenter involves 3 conditions subject to different environmental conditions with 2 types of recycled materials: recycled concrete aggregates, that is RCA, recycled concrete aggregates RCA, and recycled asphalt pavement aggregate, that is RAP. Okay, the locations are labeled by the state of origin in the US: MN, Minnesota, Colorado, and Texas. So we have factor A location, 3 locations, and based on that factor 2, that is 2 different recycled materials, that is RCA and RPA. We have 6 possible combinations along with that factor A. Okay, so Minnesota in 2 cases, that is RCA and Minnesota RPA, Colorado RCA, Colorado RPA, Texas RCA, Texas RPA. Okay, so we have 6 possible arrangements. One key physical property is the resiliency modulus, which is obtained by dynamic loadings. Generally, higher values imply a stiffer base, which increases pavement life. Do changes in location or type of recycled materials affect the resiliency modulus? That is our goal to find. If changes in the modulus are attributable to changes in location, is this change the same for both types of materials? Is it possible to answer the question of this kind if the experimental conditions, the treatments consist of appropriate conditions of the levels or the values of the various factors? Okay, so that is the goal. The factors in the preceding examples are location and type of material. Location has 3 levels: Minnesota, Colorado, and Texas. While the type of materials has 2 levels: RC and BPA. RC and RPA, sorry, not BPA. Note that the 6 treatments were chosen in such a way that each level of location is used once in conjunction with each level of type of material. In general, the 2 factors A and B are to be investigated at A and B levels, respectively. Then there are A into B experimental conditions, treatment corresponding to all possible combinations of the levels of the 2 factors. The resulting experiment is referred to as a complete A by B factorial experiment. Note that if one or more of the A into B experiment condition is omitted, the experiment can still be analyzed by two-way classification. Okay, আমরা যেরকম অ্যানোভা পড়ে আসছিলাম সেখানে কাজেই interaction থাকবে না, it depends on whether replication is available or not. But it cannot readily be analyzed as a factorial experiment. It is customary to omit the word complete so that an A by B factorial experiment is understood to contain experimental conditions corresponding to all possible combinations of the levels of the 2 factors. Okay, so if there is no replication, then we cannot call it complete because we will not have that all possible treatment combinations there. In order to obtain an estimate of the experimental error in a 2-factor experiment, it is necessary to replicate. Okay, একই combination বারবার replicate করতে হবে, repeat করতে হবে. Replication means repetition. That is to repeat the entire set of A into B experimental conditions, say a total number of R times, randomizing the order of applying the condition in each replicate. So now consider Yijk is the observation in the kth replicate taken at the ith level of factor A and jth level of factor B. Okay, so k the kth replication, I is the level for factor A, J is the level of factor B. The model assumes the analysis of this kind of experiment is really written in that Yijk equals mu alpha I plus beta j plus alpha beta ij plus eta ijk. Okay, so this is the observation. I equals 1 to A, j equals 1 to B, and k equals 1 to R. So we have the I is the suffix for the first factor, j is the suffix for the second factor, and k is the suffix of the replication. Okay, it is up to R. And this mu is the general mean, that is grand mean. Alpha I is the effect of the factor, ith factor of level A, যেমনটা আমাদের ANOVA মডেলে ছিল. Beta j is the effect of the jth level of factor B. So এখানে যেহেতু দুইটা factor, this beta is the second factor, so another factor alpha beta ij is coming for the interaction. Okay, যখন এই মডেলে দুইটা টার্ম থাকে সঙ্গে সঙ্গে তাদের জয়েন্ট ইফেক্ট চলে আসে. Okay, তাহলে we have this model. This Eijk is the independent random variables, that is error term, which has normal distributions with 0 means and common variance sigma square, also analogous to the restrictions imposed on the models on previous that ANOVA model and so on, that all the summation of AI over I and bj beta j over j alpha beta over alpha and j, I and j are equals to 0 based on the restrictions and the assumptions we have. So it can be shown that these restrictions will assure unique definitions of the parameters of mu, alpha I beta j and alpha beta ij. So we can estimate the effect of these two, but we are not going to that details of this. That is not necessary for you more often. But here, what we need that we can partition this observation yijk in 4 different parts. That is like in ANOVA, that is the general mean. Okay, this is the factor A effect, that is this is y bar yi dot dot bar. Okay, so we have only factor A effect and then summing over the j suffix, summing over the j and k suffix. So I dot dot bar. Okay, so this is the factor A effect if you subtract that from the ground mean. If you consider this is the y dot j dot bar. Okay, so this is the factor B effect if you subtract it from the ground mean. Okay, y dot 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 bar 3 dot bar means if you sum all the values, all the level combinations and divide by the total number of values. Okay, suppose you have 3 by 2, then 6 uh, 6 possible treatment combinations or experimental conditions. Then if you divide by that 6, then it will produce you the grand mean. Okay, like you did that in ANOVA, divided by 15. Okay, if you divide by over suffix of j, over suffix of j, that is j equals 1 to b. Okay, j equals 1 to b, if you can remember here, j equals 1 to b. If you sum over j divided by that j equals 1 to b, I equals 1 to a, k equals 1 to r, it will have values later on for numerical example. So based on that, you know this is the factor B effect. Okay, and this is the interaction effect, alpha beta. Okay, alpha beta effect. If you see alpha beta ij is 1, ij is 1, and k is the there is no k here, so it is actually that alpha beta combination. So it is actually the interaction effect, and this is the error term when you subtract from the actual observation to that replication variable. So based on that, we can actually find the sum of squares. Okay, sum of squares, you know, from the ANOVA model. In ANOVA we had only 2 parts because we had 1 factors, but here we have 2 factors, so we will have 4. Because of the 2 factors, there will be an interaction effect. So this is the sum of a square. This is the sum of a square due to that error term. This is the sum of a square due to A, due to B, due to interaction, and due to error. Okay, so we call it sum of a square of treatment, sum of a square of A, sum of a square of B, sum of a square of AB, and sum of a square of error term. Okay, give me 5 minutes. There is someone in the gate. Okay. Okay, so you have to calculate all these expressions. Okay, so 1, 2, 3, 4, 4 expressions for 2 factors. You know that this will be a relatively complicated example if you want to do that in exam hall. Okay, so you will be careful on that, that whether you can calculate all this, or and it will be a little bit time consuming. Okay, so we will consider that not to put that in the final exam or in the in courses, because it will be a lengthy one. Okay, so these are the sum of squares for that we have 1, 2, 3, 4 in the right hand side, and in the left hand side we have treatment total treatment sum of square 2. Okay, so at least you have to calculate 4 of these, 4 of these to find the all possible that is 5 expressions. এর মধ্যে আপনি যে কোনো 4টা আপনাকে ক্যালকুলেশন করতে হবে। যদি ডান পাশে 4টা ক্যালকুলেশন করেন, সাম করলে টোটাল সাম অফ স্কয়ার পাবেন, অথবা এদের মধ্যে যে কোনো 3টা করে এটা করলে তাহলে টোটাল সাম অফ স্কয়ার থেকে বাদ দিলে আপনি রেস্টটা পাবেন। যে কোনো ভাবে আপনাকে এই 5টাই ক্যালকুলেশন করতে হবে if you want to perform that. Okay, total degrees of freedom a, b are -1, so it is actually the total sum of square degrees of freedom. Factor for factor a -1, for factor b -1, for interaction a -1 into b -1, and for error term ab into r -1, that is the degrees of freedom. You will need that for producing ANOVA table, and further than F statistics for each and every test you have to do for factor A, factor B, and interaction. Okay, so that is the job you have in hand. Let us go to that example we studied first, that referring to the recycle example on page previous slides. The experimenter obtains values of the resiliency module from, say, 3 replications of the experiment, and that is we have had this data for 3 replications. Okay, and all possible combinations of that location, 3 locations we had, and 2 type of material combinations. Okay, so you have 6 possible combinations, and then with 3 replication. So perform an analysis of variance. We have to perform an analysis of variance based on these 2-factor experiment and test for the significance of the factorial effects using, say, 1% level of significance. That is the problem. So we will have that null hypothesis that the 3 alphas, whether for factor A equals 0, for factor B, whether the 2 parameters, the 2 levels parameter are 0, and all possible treatment combinations, whether we have 6 possible interaction, alpha, beta, 1, 1, 1, 2, 2, 1, 2, 2, 3, 1, 3, 2, or 0 or not. Okay. Alternative hypothesis is that the alphas are not 0, betas are not all 0, and alpha beta interaction are not all equals 0. So we have that level of significance is 0.01. So based on that calculation, you have to compare for replications, reject null hypothesis if your F statistic is greater than 6.93 for the values of 2 and 12. Okay, for factor A. Okay, আমাদের টেস্ট এখানে কতগুলো করতে হবে? A ফ্যাক্টর A এর জন্য করতে হবে, B এর জন্য করতে হবে, ইন্টারঅ্যাকশনের জন্য করতে হবে। আর যে ফ্যাক্টর A এর জন্য, যেহেতু আমাদের এক ফ্যাক্টর A এর 3টা লেভেল ছিল, তাদের ডিগ্রিজ অফ ফ্রিডম কত হবে? ডিগ্রিজ অফ ফ্রিডম হবে 3 - 1 into r minus 1 into ab into this error degree of freedom, that is 12. Okay, so for factor b আমাদের হবে that we have, for factor b we have that 3 minus 1 and error degree of freedom 12 minus 1, so factor b. So reject null hypothesis if that f is greater than 10.04 for b minus 1, that is ab into b minus 1, 12 degrees of freedom. And for the interaction, reject null hypothesis if f greater than 6.93 for the values of f with that ab interaction এর জন্য সেটা হবে 2 into 12 degrees of freedom. Okay, so it is the best practice to use computer softwares to obtain analysis of variance, because you have to test 3 different possible level combination. So we for calculation with hand it is a bit difficult, so we here if you use that our softwares you can get that easily with that degrees of freedom and sum of squares and mean sum of squares, and that f, you know, if you divided this part with this one, then you will produce that mean sum of square. If you divide that mean sum of square with error sum of square, it will produce that f statistic, and computer can produce the p-values based on this f statistic. Okay, based on this f statistic, this is the f statistic for b, so it is actually coming from here. If you divide by this one and error degrees of freedom, then it will produce mean sum of square and then f. So if you see here, the p-values are actually smaller. Okay, p-values are given in the last column of this table 1. F equals 12 for factor b exceeds that 93. Okay, for 1 and 12 degrees of freedom, that is f equals 16.1 for ab interaction exceeds that 96.93 for 2 and 12 degrees of freedom. In both cases, p-values are extremely small, so the null hypothesis will be rejected. Okay, if you can remember, p-values, if p-values are less than 0.05, okay, so your null hypothesis is rejected. Here you see your p-value is 0.03. Okay, 0.000.001. আমাদের significance value দেওয়া আছে 0.01, so 0.01 এর থেকে b এর p-value ছোট. Okay, so null hypothesis for beta rejected. Neither of beta 1 beta 2 are 0. Okay, neither the interaction is 0. Okay, so as the interaction is significant, that is it is not 0, so the a factor p-value টা কিন্তু 0.03. so if you consider with that 0.01, it is actually higher, right? But as the interaction is significant, you cannot omit that factor a also. Okay, so that is the findings we have. That is the findings we have. That is all the factors a, b, and interaction are significant. That is, they are not equal 0. Okay, এই মডেল থেকে আমরা পেলাম যে একটা ইন্টারঅ্যাকশন গুলো হাইলি সিগনিফিক্যান্ট, বিটা ফ্যাক্টর গুলো সিগনিফিক্যান্ট। যেহেতু ইন্টারঅ্যাকশন সিগনিফিক্যান্ট, এই জন্য তার আলফা ইফেক্ট টু সিগনিফিক্যান্ট বিকজ অফ দিস, দ্যাট ইন্টারঅ্যাকশন ইজ সিগনিফিক্যান্ট। ওকে, আমরা এটা আর সফটওয়্যার ইউজ করে ইজিলি করতে পারি। যেমন আপনারা যদি কখনো কেউ পিএইচডি করেন বা ফার্দার রিসার্চ করেন, তাহলে দেখবেন যে দিস উইল বি ভেরি useful software. We write it capital R to note that this is the statistical software R. It says the data set is named C13XL1. Okay, this is .txt means this is a text data. Okay, equals means the first column is the name of the variable. Okay, model is the linear model, and this is the dependent variable name. Curl, this indicates formula that alpha a, b, and ab interaction, factor a, factor 2, and interaction. This is the data name, that this is the date. So they fitted ANOVA model. Okay, so we had to do that. So this is the simple art software that will produce you everything. This is a bit complicated calculation. You cannot possibly. You can, but it will take time. So we cannot introduce that in your exam because it will be time consuming, and when a calculation is boring, is laborious, so it will not facilitate uh, for you to solve in the exam. So we will be away from it. So as it is in your syllabus, you have to learn it. So you will practice it, and you may not get it in the exam because it is a two-examiner system we had. I don't like to prefer it as it will be time consuming, but it can come to an exam because there will be another examiner, so you have to learn it, but uh, you can you may not like it, okay, because it is a bit complicated, it is a bit time consuming and laborious. Okay, so with this term we have all the items in our syllabus is discussed. Okay, another topic from here that we can find the confidence interval. Okay, আমরা আপনাদেরকে estimation confidence interval পড়িয়ে আসি। এখানেও আপনি যদি ফার্স্ট ফ্যাক্টর এ এর জন্য এর যে কোনো কম্বিনেশনের জন্য তাদের কনফিডেন্স ইন্টারভ্যাল বের করতে চান, তাহলে সেটা বের করতে পারেন যে i1 আর i2 যে কোনো, যদি এই ফ্যাক্টরের অনেকগুলা লেভেল থাকতো তাহলে তাদের যে কোনো দুইটা মিনের ডিফারেন্সের কনফিডেন্স ইন্টারভ্যাল এটা। ওকে, দেখেন s স্কয়ার divided by 2y br, this is the error degrees of freedom, এখানে error degrees of freedom এর যে b dot into r. So this is T alpha, means that T degrees of freedom alpha by 2. It is actually coming from that one Ferroni test statistic we have. But you directly can use this formula that S square is coming from SSC, that is error sum of a square divided by the degrees of freedom. These are the differences of the two mean. So you can, if you put that minus sign here, you will get the lower limit. If you put plus sign here, you will get that upper limit of that factor A এর দুইটা লেভেলের ডিফারেন্সের কনফিডেন্স ইন্টারভ্যাল। ওকে, সিমিলারলি ইউ ক্যান ফাইন্ড দ্য factor B এর যে কোনো দুইটা লেভেল কম্বিনেশনের ডিফারেন্সের কনফিডেন্স ইন্টারভ্যাল by putting that it is actually y dot j on dot bar minus y dot j2 dot bar. j1 j2 মানে বোঝানো হচ্ছে যে b এ ফ্যাক্টরের যে কোনো দুইটা মিন, ওকে, যে কোনো দুইটা লেভেলের মিন। ওকে, so T alpha is coming from the table, S square is coming from SSE, and 2y divided by that A into R, these are coming from that for B. So B এর দেখেন B মানে J suffix এর জায়গায় J suffix নেই, শুধু আছে A আর R, that is I and K. এখানেও দেখবেন যে এখানে যেখানেটা ছিল না, এখানে ছিল হচ্ছে A ফ্যাক্টর, কাজে A নেই, দেখছেন B divided B into R, rest always this is the formula. So if you are interested, someone you can study that and solve it with manually using this formula given here. Okay, you can calculate this like ANOVA from that two factors interaction. So what is different from that ANOVA model here, that in ANOVA we had mu plus alpha plus EIC. Okay, now we have two factors, so mu plus alpha plus beta j plus alpha beta ij plus EIJ. Okay, so for two-model interaction, this is the extra term you have to study. Do you have any question? Okay, if we don't have any question, then this is the end of our class today, and this is also the end of our session. Okay, so this is not end. If you have any question, if you have any problem, then don't hesitate to contact me. Okay, by email or via the CRs. We have study desks also. So if you have any sort of problem anywhere, and forget not to submit the assignments, your in courses mark may be attributable based on the assignment. So you must submit those assignments on time. Okay.